gravitational potential can be expressed this way. So R sub 1 is the distance between the two objects with masses m and m sub 1. This is the distance. And if you consider the partial derivative with respect to x, it's going to be expressed this one. So first term of the equation and the second term in the right hand side of the equation is quite easily written if we use a gravitational potential Gm sub 1 over R sub 1, Gm sub 2 over R sub 2. Okay, so the right hand side of the equation is simplified if we use the gravitational potential. Also, centrifugal force is quite simplified. So in this case, is omega is a constant. So 1 over 2 omega square x squares can be expressed omega square x. So this terms is quite easily simplified. So we'd like to use the same expressions for the centrifugal potential, like a gravitational potential. So we add the y squares, but the partial derivative with respect to x becomes 0. So even if we add any y squared terms, it does not affect to the equations. So we just, because lambda x 1 over 2 omega square y square is equal to the 0. So we introduce a centrifugal potential as a single forms to simplify the equations. Then finally, basic equations is expressed very simple forms. And u is 1 over 2 omega square x square plus y square. This is the first term is a centrifugal potential and the gravitational potential due to the two objects with masses of m sub 1 and m sub 2. Equation is significantly simplified. This is the end of this session.